Yeah, everyone, let's look at achieve section 4.4 number 3. We're to determine the intervals where this function here, and again, your function should be something similar, is concave up or down, and then find points of inflection. And very important, read the directions carefully. It says in parentheses there to give your answer as a comma-separated list of points in the form ordered pair, basically x comma y, right? It wants the exact form. It wants the actual point of inflection. A lot of times in my lectures in class, I'm giving you or asking just for the location, which would be just the x value, right? It's located at x equal whatever. How do you find the corresponding y value? Well, it's on this function, so plug in the x value into this function and you'll get the output. So for this problem, I'm going to take the first and second derivative. Very easy. Hopefully everyone knows the derivative of 8x cubed by now. Bring the 3 down. That gives me 24x subtract 1 squared. Bring the 2 down, minus 14x to the first. There's my first derivative. Second derivative, similarly by the power rules, bring the 2 down, 48x, and then derivative negative 14x is negative 14. Here's my second derivative. When is that second derivative equal to 0? Well, I set that equal to 0 and I solve for x and I get 7/24 when I simplify, and you should do that. And so I want to do next a sign check. Very important on the test that you show me a sign check for support. You will not get credit without a sign check. You have to show this, okay? Something like this. Now you can use a table. You know, look at the problems in the text, in the ebook. You can look at some examples there. They use a little table. I use this little, if you look at any of my lectures, the number line is down here. Domain is all real numbers. There's 7/24. The second derivative is 0 at 7/24. So I'm writing above the number line the sign of the second derivative. And then I just check a value that's less than 7/24, like 0. If I plug 0 in, I'm going to get negative 14. Everything's negative here. I'm putting a negative for that. If I plug in something greater than 7/24, like 1, plug in x is 1, I get 34. It's positive. Okay, that means that the function is concave up, remember, when the derivative is increasing, which occurs at when the second derivative is positive. So the second derivative is positive for values greater than 7/24. So on that interval, the function is concave up. The function is concave down on the intervals where the second derivative is negative. So that's on that interval there. Obviously, we have a change in sign of the second derivative, meaning we have a change in concavity at 7/24. So we have an inflection point at x equals 7/24. This is usually what I'm asking you to give. They said to give this the ordered pair. So I'm going to take x and plug that into the original function, not the derivative or the second derivative. We already know what we get when we plug it into the second derivative. We get 0. What do we get when we plug it into the actual function? You've got some pretty nasty fractions here. Using your calculator's convert to fraction button can be helpful here, because they do want the exact value. But you can see we get down to this simplified fraction here. And so the point of inflection is the x coordinate, the y coordinate. That's what they're looking for. That's the location on the actual graph. Okay, I hope this helps clear up what's going on here. And if there's other questions about this one or others, please let me know.